Hello everyone, my name is Emily Hardy. I'm a simulation engineer with FlexSim in the US headquarters office. And today we're going to be speaking about a modular trolley warehouse that I recently built for one of our clients. So as a bit of background on this model, this was built for a very large production and warehousing company based out of the US. They are involved in both producing the product that they're making as well as warehousing and shipping it out. So for the facility that we were modeling, they had products that were arriving from internal production as well as for external production. So within the warehouse, we had a mix of products arriving from different locations. One of the main considerations for this model was that we had a limited number of trolleys that transport the pallets around the warehouse. They move them from shipping to the warehouse and out again, depending and through various locations. So the pallets are resting on these trolleys, which carry them from place to place. With the model, there are several considerations that the client wanted to take into account. They wanted, although we were basing this on one specific location of their warehouse, they had multiple similar warehouses in the area that they wanted to be able to replicate this. And so they wanted to be able to scale the warehouse up and down, as well as scaling the trolley system in order to accommodate different layouts. With the same goal in mind, they also wanted to be able to scale up the arrival and departure rates of the pallets from each location, both internal and external. They had multiple pallet types that had different velocity requirements. Some of the products were more prone to slipping on the pallets and needed to be moved more slowly than other boxes. And so we needed to also keep some of the pallets are moving slower than others, while others can be moved more quickly. While sizing the warehouse, one of the things that they wanted to find for this warehouse was to find the right number of trolleys and forklifts. Of course, if you increase the number of trolleys and forklifts, you often can move things faster, but you'd also run into the issues with traffic, as well as additional expense. They also wanted to be able to change the warehouse size. Although we were working with an already developed warehouse, they wanted to also look at some future states. And so they wanted to be able to change the size of the warehouse to run different situations. And lastly, one of the things that the client wanted to use was they wanted to be able to manually apply breakdowns on some of their machines. And so they wanted to be able to do that through the GUI. So with those things in mind, let's take a look at the model itself in FlexSim. So we have the model here. We can see in the 3D warehouse we have some low bays as well as high bays. We have a number of wireframe racks using our new warehousing system. We can also see that we have this red track running around the warehouse. This is the track that the trolleys run on as we run the model. So we have things arriving from different locations. We can see that we're picking up our pallets from the inbound ships, as well as our internal production coming from the bridge here. Now, as products arrive and they need to be transported, they work on both conveyor systems, the forklifts, and our trolleys, which will run throughout the system, picking up and unloading all of our different pallets into both the high bays and low bays that we can see here. So the client really wanted to take full control of this model. This was less a model that I was coming in to give them one result and a model that they wanted to use for their own purposes in order to make different arrangements. So for example, the model controls were very important to them. So for example, they wanted to be able to adjust our internal pallet rate as well as our outbound shipments. They were also experimenting with the number of trolleys that we had running around the system. The trolleys, of course, cannot overlap, and so bringing in too many did result in some traffic. So they were experimenting with a few different numbers of those trolleys, and as well as with the fork trucks that are used for both internal and outbound systems. Now, they had some concerns with their two elevators bringing products down from the bridge here. And so one of the things that they also wanted to do was to be able to create manual breakdowns on our elevators here. And so, of course, breaking them both down will build up product in the bridge and prevent it from moving on. And then they could turn it back on when they were ready to. So they want to experiment with some manual breakdowns there. They could also resize the warehouse from the beginning by turning on and off our different aisles, or they could also induce breakdowns in our warehouse by turning off certain ASRSs here by using these checkboxes on the aisles. So again, giving the client full control of the model rather than creating a set situation. We also have the breakdown of the different velocity restrictions on our different pallet types, as well as lots of different unloading and loading parameters. So based on this, you can see that we have our ASRS that is picking things up. We have our conveyors working in tandem with the trolley, dropping things off, picking them up, rotating, picking up, etc., and just storing things in different locations. Now, as the model runs, we do get more buildup within the warehouse. Of course, just running it for 37 or 40 minutes here, we don't get much buildup. But as the model runs, we do fill up the warehouse, and things do tend to get built up. When we leave the warehouse, regardless of where we come in from, we're going to go out through these shipping lanes and then ship out through the docks. And so we do have a set number of shipping lanes that was already built in the model, so that was constrained to a set number. Although, as we ran the model, we found we ended up changing considerably the number of fork trucks and trolleys. We originally had much fewer trolleys and too many forklifts. So we were able to reduce the number of forklifts that we did need, but we did increase the number of trolleys in order to get this system moving more smoothly. As they didn't want to purchase or return more of the trolleys, it was helpful to them to have the model in order to experiment with it in the risk-free environment of FlexSim, rather than bringing it into the real world and having, the problems of perhaps overspending and going past budget or coming up with traffic that they could have otherwise avoided. So with this scale, we're also able to manually change the number of internal pallet arrivals as well as the number of outbound shipments per week as the model runs. Again, the client did want the control of the model rather than having set situations. They wanted to be able to change it as it ran, which was sort of a new challenge with some of the things. As typically, I think a lot of the models that I've worked on, they did have more of a set values at the beginning rather than changing as the model runs. So yes, using this model, they are able to correctly size some of their warehouses, and I believe they have plans to use the same model in order to create some future state planning for some other warehouses that are very similar in the future. And so we're able to use all of the controls that we'd already defined, and so to use this for more than just one warehouse and for more than just one facility. I think we have a few minutes for questions. If anyone has questions about this model, I'd be happy to answer any. I think it was about 4 to 5 weeks on this model. Yes. Yes.
Well, my question refers to the relationships that you have in your file. Since you created an interface where you can change some parameters, it still requires to have software. So does your client give you inputs on base you can make experimental changes in the models, or you enable them to do it?
The hope was that the client could do this for themselves. So we actually had created, for example, I had set this up to sort of the maximum size of the warehouse that they had wanted, and then they were able to sort of close off different aisles of the warehouse. So the hope was that they could take it and on their own do it. Part of it was that they had some proprietary concerns, and so they wanted to be able to use this for more than just one facility in order to not give out as much of their information. So I was working within some ranges that they had built, but the hope was that they could use the model themselves in order to Yes, so the project was handed off to them with the hope that they would continue it and create different situations on their own rather than handing them the results.
And yes. They of course needed to have flexible.
Yes, so they were licensed. This is a company that we work with quite a bit. They had many licenses already, and so they had used those, and they had some engineers in their team that were interested in working with it a little bit more independently.
Here we can see that we can change manually the parameters. Do you prefer some kind of the automatic analysis about the required resources for the change demand, for example? For this example?
So they were using. Sorry, what was? What do you mean?
So I mean that the model can analyze that for example changing demand and propose the optimum resources required in this system.
Yes, so they were trying to optimize it, and so part of that is we have some of the outputs that they were looking at in order to, so they were trying to reduce, trying to maximize utilization while not having product build up in certain spots due to too few resources.